Now it's going live.
So we should have a contest to see how many different definitions we can get.
All right, I think we're live now. Should we go ahead and get started? 6:35. All right, my name is Brian Ketelsen, and I'll be your organizer tonight and your presenter. So I would like to announce our first presenter. His name is Brian Ketelsen. He's the organizer of GopherCon, author of Go in Action. I've got discount codes. If anybody doesn't have the book, I can get you a 40% discount tonight. And what else do I do? Run the Gopher Academy blog and a few other community things. I like building community. It's kind of my hobby. Go is my profession, and I'd like to talk about generating code tonight because it's my favorite thing in the world. So usually every slide or every speech starts with a, why you should pay attention to me. And my why you should pay attention to me slide is because I'm lazy. I hate writing code. I like solving problems, but I hate writing code. So I like to generate all the things. In fact, our Slack room for Goa has a very nice little Slack bot script. Every time you type GATT, you get that beautiful image, generate all the things. So the reason I like to generate code is because when I solve a problem, typically I will write a first iteration, and then I'll write another one, and then I'll refactor it. Usually it takes me 4 or 5, maybe 20 times. I like to refactor before I really get a pattern that I like and that I want to apply everywhere. And then it's cut and paste that pattern to every different domain that you want to apply it to. That's annoying. I would much rather take a template and apply that template everywhere. So beginning 2015 or so, we had a tiny startup with just a few people and a really short timeline to get a lot of code out. I started writing code generators in Go. I really like code generation as a concept because it's a single source of truth. You have an input piece, and you run it through the generator, and you get output. The input's always static, or when you change it, your output changes. But that input is the thing that you check into source control. It's your source of truth. I like that concept because it allows you to make changes and generate lots of code rather than make lots of changes in lots of code. So there's a lot of different code generation tools for Go. If you haven't used gRPC yet, it's a very fast RPC library, and it requires protobuf installation. Really nice to use gRPC. There's Gen and a dozen other generics substitutes for Go, which allow you to run Go generate and get generic type things based on your structs. It's really easy to do code generation in Go because Go has really nice tools to let you parse the abstract syntax tree, and it's got some nice, powerful text templates in it. So you can easily feed it data and output nice information. So for me, I never want to solve the same problem twice. Once I solve it, let's make that canon and apply it everywhere. Welcome. So about November of last year, after spending the summer writing code generation tools, I happened to stumble across a project on GitHub called Goa, written by Raphael Simon from RightScale, and I immediately fell in love. Goa espoused all the same principles that I've been talking about, having the single source of truth, writing good, clean code in a design, and then applying that through code generation to your API. Goa started as an API generator, and that's still its main focus. Because I spend a lot of time writing APIs, it definitely caught my attention. The code was really clean, was pretty, uses net context everywhere, which I believe you should do, and it generates really clean boilerplate code letting you work on implementing the controllers for your API, the business logic. Welcome. So the idea behind Goa is that you spend the lion's share of your time writing your design. The design is the input to the code generator, and it's the thing that feeds into the system before you generate code. Goa's design is written in a DSL that's written in Go. So you'll notice here we're using dot imports. Don't mention the dot imports. But it lets you have a pretty looking DSL almost as if it were Ruby-ish. This particular DSL declares an API at the top, and it's got a title for the API, a description, the host for the API, and the scheme. It's HTTP. And then in the API, we're declaring a resource with an action. That action, this particular resource adds a left and right operand together and returns the addition, the sum. So you can see that it's really clean API that allows you to declaratively design your API. Too many APIs in that sentence. I mentioned dot imports. We only use dot imports in the design, and you don't have to. You could write Goa dot whatever in your design, but it's really ugly. So in our designs, we don't use the fully formatted package names. We're using dot imports. Just move on. It's okay, I promise. So behind the scenes, each one of those functions in the DSL is actually populating a data structure. And that data structure is a description of all of the pieces of your API. We'll take those data structures and then use them as an input into a template engine that will then generate the code that becomes your API. The nice thing about this process is because the data structure is aware of what's going on in your DSL and it's aware of your design, the generation engine, you don't even have to generate the code before you can find errors. So we know that back here when we're declaring an action, that action has to have a response. It has to have parameters. It has to have a route. If you don't declare a route, you get an error at compile time. Before you even try to generate code, you'll get an error. So the nice thing about Go and having a static code generator tool like this is that it prevents you from causing bigger errors right up front. So in Goa, the design code typically lives in the design package of your project too. It doesn't have to. You can put your design package anywhere. And maybe a little bit later, if we have time at the end, I'll show you how I'm doing it at work, where I have a project with only design packages, and we use that to generate different APIs throughout our ecosystem at work. So we have shared design packages, which is a really neat feature. Your design typically consists of one or more Go files. It doesn't have to be one. It doesn't have to be five. It can be as many as you want to make it clear, because they're really just function declarations. But there are the following parts. We've got an API definition, which we looked at just a minute ago. Resource definitions, that manages your routes, the actual resources in your API. Media types, those are the things that you're sending back to the consumer of your API. A media type might be a book or a user, some information that you're sending back to the consumer of the API. User type definitions define the payload, something that somebody's posting to you. So on a create or an update method, you've got a payload. That's a user type definition. This is it was a departure for me when I first looked at Goa, because in all of the code generation I've done in the past, I usually have a model, and then the resources all the way through the API really just match that model. We're posting a thing and we're getting back a thing. Goa separates those concerns nicely, and after thinking it through and talking to Raphael about it, I appreciate it more, because typically you don't want your users to be able to update all of the things in your API, and sometimes the actions in your API don't at all represent the model in your database or in your system. So having those two separate made a lot of sense after I thought about it more. And then the last API definition is security definition, which actually landed today. I said it was going to land this week, but it landed this morning, so I don't have a lot of information about that yet. So the API definition has information about all of the basics of your API. It's got the host, it's got contact information, it's got license. Almost all of these features of the design are driven by the Swagger definition. So as you input information into the DSL, think at the end of this, what we're going to create is a field inside the Swagger definition that will describe the API, where the endpoints are, where the license is, where you can get help for the API. All of that comes from the design through the generation engine into Swagger for these pieces. So here's some more of that API definition. You notice that it's got a base path and a scheme and a host listed. And then the last thing down here is a response template. This is, it's almost cheating in code design, because it allows us to define a static template that any of our resources can use. So our response template here is called created, and that means that any other resource can use this template as the response for an action. These are called traits. Traits are reusable chunks of your API design. So the media types, again, these are the things that we're sending back to the consumer of the API. This one is a review. Sometime before we opened the CFP, the call for proposals in GopherCon, I decided that we needed to write our own CFP app. And I was crazy because I've got a full-time job and managing a conference, and it never did happen. But it's been a really nice proving ground for me to play with Goa because it's a model that I can easily think through and work out. So this is a chunk of the media type definition for Congo, which was going to be our CFP app for GopherCon. This particular resource is a review. So if someone submitted a talk proposal, the different reviewers could review this. So it's got simple attributes, attribute of an ID, of an href, which is actually the link to the proposal itself. You can comment on that attribute. You can have a rating for the attribute. And then one of the nice things that I really learned to appreciate about Goa is this concept of views. So the attribute definitions are up at the top. Views are slices of those attribute definitions intended for different purposes. If you're a reviewer, you probably don't want the public to see your comments if they're private comments. So you might have a view definition called public that didn't include the public, or didn't include the comments, but it did include the rating. So you can create these different views meant for consumption by different people. And I find that really powerful. For example, I've got a tenant-based API at work. We've got views for administrators and views for customers. The administrators can see all the things, the customers can only see chunks of the things. It's still the same model, still the same media type, but we've got different views and we don't have to create two different structures to worry about it. We just create one view on the same master structure. Then user type definitions, these are the things that you're putting and patching and posting. This one is the review payload. So if you're going to create a review against a talk proposal, you really only need to post two things, a comment and a rating. And then we actually have some requirements inside the DSL here. So if you're going to post a comment, it has to be at least 10 characters long, and it can't be more than 200. If you're going to make a rating, it's got to be between 1 and 5. So the nice thing about the code generation is you don't have to worry about those requirements in your controllers. If the body that's posted to your controller doesn't meet these minimum requirements, you get back a bad request, and it never hits your controller. So Goa generates, yeah, go ahead. It does support regex. There are regex filters for the different requirements, and you can do a lot of really powerful things with them. It even has some RFC type requirements. So you can say this has to be an email formatted field, or it has to be a date formatted string. It's got some nice ones in there. And then your resource definitions, these are the things that define the paths of your API. And it's where you determine which things are posted and which things are returned. So the resource definition ties those media types and user types together. This particular path is for the list of a review. So if you wanted to list reviews, you would call get on/review, and you would get back a collection of the review media type. So you get back an array, a list of reviews. And we would use the default view for this particular one. You can actually list multiple views, and what's missing, oh no, the response is right here. So we're using that response trait that we defined earlier to cheat and reuse that particular chunk of API definition. Now you could edit code in there. So once we've built all of that DSL, which is really just a handful of functions that we're calling in a Go package, we call GoaGen, which is the command line app that generates your DSL. Pass it in the package that represents your design, and the bootstrap flag that generates the entire application. So from that, you get a lot of good stuff. You get an application package. The application package has the controllers, the routing logic, all of the type conversions that move from a media type to a user type, the type conversions that filter down one of your media types to a smaller view, and then all of the code validation so that you don't have requests coming in that don't meet the code, the validation rules that you've created. Goa also generates a JavaScript client for your API, which is really handy if you're making a web app that needs to talk to the API. Just import that JavaScript class, and it's got all of the rules built in. Very nice. It creates a Swagger definition and a Go controller to mount that Swagger definition. Welcome. And then a JSON schema file that you can send out to consumers of the API if you want to. There's a Go client package in CLI, so if you want to use this API from other parts of your own code base or give it to other consumers, you can just pass out that package or give them the URL to it. And then a main.go to wire it all together. And then on the first time you run it, you get a controller for each of your resources that's generated for you, but they're stubbed. Your business logic is going to go in there, and it just has a little to-do, put your business logic here note in it. So you get the full Swagger definition. You can use Swagger API and instantly get a Swagger document. Has anybody seen this, the Swagger, the pretty Swagger thing? Let me pull it up because it's nice. So this is what Swagger looks like for an application. In fact, this is this application. The Swagger design reads the Swagger specification that's generated by Goa, and you can click on each of the different actions and see the body that's expected or the body that's returned on the gets and posts. You can see what responses are going to come back or could come back. So let's look at the get one here. So the get for accounts is going to retrieve an account with a given ID, and it might look roughly like this, and it's got some nice lore, some text in there. So if this were actually a running app based on the Swagger definition, we could put in a value for the account ID and hit try it out. It won't work here because the app's not actually running. But Swagger is a really nice way for the developers, the consumers of your API, to see what the contract is between the API and you. So you can see all of the different actions for accounts and then the bottles that are in the account. We'll talk about that later. So really, for spending a couple minutes creating a design, you get a whole lot. You get a working API. All you need to do is bring in the business logic, send data back to the consumer. It's a pretty big win. And the code that is generated is really clean, idiomatic Go code. And I haven't seen anybody complain about it yet, which is rare in the Go community because usually somebody has something to say. So does it sound good? Does that code generation thumbs up? Yes. Heads nodding. Good.
Questions?
Sure.
All right. Well, first one was, is there anything like rate limiting or any other logic you can add to your resources?
Absolutely. Goa has a lot of middleware, and it's really easy to add new middleware.
Okay.
I don't remember specifically a rate limiting middleware, but you could take an existing Go rate limiting middleware and wrap it with just a couple lines and get that too.
Okay. Then another question. So you have a bootstrap statement.
Mm-hmm.
Does that mean if you change your spec but you have an existing code for other controllers, you can choose what to actually generate or say extend your code base? That's
a good question. The first time you run with Bootstrap, it will generate the app folder or the JavaScript folder, the main.go, and then the controller files. If you were to run Bootstrap again, it wouldn't touch main and it wouldn't touch your controllers because it doesn't want to assume that you really want those things overwritten.
Okay, but you could say choose just Bootstrap this one controller or something like that.
What I do if I really want to regenerate that controller, I'll just save off the controller as a different name and then run Bootstrap again, and it will replace it with that stubbed out controller.
Okay, that's fair.
The controllers and main are the only ones that are guaranteed not to get overwritten.
Okay.
Everything else is fair game. So when you regenerate after you've made some design changes, the app folder gets deleted and recreated. The JavaScript folder gets deleted and recreated. Really, your design and your controllers and your main file are the only files you should change in your Goa project.
Okay, so another one. I was looking at the media types and the user types, and in our current situation, we have microservices that have sometimes they need to be regression sturdy, if I can call it any other word, where they should understand versioning of different types of media or user types in your lingo.
Sure.
So is there any support for, say, versioning those? And
Absolutely. Goa supports full versioning. You can define versions, and each version is actually a separate version of that media type. And then you, in your main, you would set up the router to route the versions to the correct.
So the resources
controllers
would be able to list what versions of things they can install?
Yes.
Okay, cool. And then another question that came up was, is there any sort of unit testing generation or anything that would say support, at least just giving you a few different, say, like scenarios, such as either acceptance tests that would run your command line client against some particular resources, or anything that would let you, because again, while you Swagger with, say, great, and I think it's like, what's the tool called again? It's Napa, and then there's a few other languages. They'll actually have unit test pieces where you can go and say, oh, by the way, this should return a 400 if you do this, or this should return a 401 if this happens. And those sorts of things, I would imagine the controller is going to really have to be, in charge of. Say, okay, does the user exist?
Right.
Well, okay, then it's a 404. It's not there. Oh, they do exist, but you're invalid. Okay, then 401. That's
So the answer to your question is no, we don't currently generate user acceptance tests. It would be really easy to do because we already have the design up front.
Right.
And given the Swagger specification, you could use any other tool that,
Right.
that will test given a Swagger. I've used, can't remember the name of the tool off the top of my head, but one that you point at a Swagger definition. And,
yeah, there's some that exist. Again, it's nice when you get to test it on the Go side because it's so much faster, and then you also get the benefit of being able to do Go bench.
Right.
And so that was just something else. Okay, that's
Yeah.
my 20 questions at the moment.
So the good news is because you've already got the design, it would be really easy to make your own tests for that. And I'll go into how to extend Goa at the end, towards the end of this.
Okay, cool.
So to reiterate the workflow, you write your design. That's where I spend all of my time. You think through what people are sending you, what's required. The more time you invest in your design, just like any other software project, the better the output will be at the end. The fewer changes you'll have to make later. Then you run Goa Gen with Bootstrap. You can also run Goa Gen to get individual pieces. If you just want to regenerate the application folder for your controllers or for the validations, you can do that. So then you wire up your controllers, you replace the to-dos with your actual business logic, and then you compile it, you run it, and you smile because it's awesome. When you realize that you forgot a field on a particular model or a particular type, you just go in and change the design and regenerate and smile again. Like I mentioned before, Bootstrap and main, you can do Goa Gen main, which will regenerate your main and your controllers. They will not overwrite your main.go or your controllers. So if you want to get them generated again, just delete them or rename them so that it will get regenerated. Really, the design is where all the power is, and it's where the most nuance is with Goa. Goa has a wonderful website with more documentation than most apps that I've seen. Definitely spend some time reading through that documentation and understanding the relationships between the different aspects of Goa and kind of the correlation factor. If I make a change to this media type, how does that bubble down to what's going to happen in my controllers, for example? So you might be asking yourself, I don't write APIs for a living. Why should I care? DSL engine is a package inside Goa that is an abstraction of the code generation utilities that allow you to make your own DSL for any purpose. It was actually one of the first things I did after I shouted from the mountaintops, hey, this is a really cool project. One of the first things I did was submit a PR saying, it would be really nice if you just took this API generator and made an abstraction out of it so it could be an anything generator. And the project owner, Raphael, agreed that it was a pretty good idea. And now we've got a DSL generator that will let you build a DSL for anything. And I'll show you an example of that in a moment. The second thing I did was write my own generator for Gorma. So with Goa, you generate your API all the way up to the data layer, the business logic. With Gorma, you take that same design, sprinkle in a few extra function calls, and now it generates everything from soup to nuts. So you get your API all the way down to the database layer, and it will generate models for you with all of the getters, the setters, the updates, anything that you would want to do out of a database. It's very smart in terms of updating only the fields that have been changed in your API, and it understands and respects all of the pieces of the design in Goa, so you don't have to think really at all about what's happening in the database layer, because you've already thought that through on the design of your Goa app. These links will be available online, but you can see the web documentation for Gorma. It uses Gorm. Has anybody used Gorm before? Gorm's a relatively lightweight ORM. ORMs aren't popular at all in Go, so you have to say it with a little bit of warning. But I like Gorm because it does the smart thing, and it hasn't bitten me yet in terms of doing stupid things. I hated Active Record in Rails because it was always doing 40 more queries than I thought it should be doing. Gorm doesn't do that. You have to tell it to actively go off and preload, eager load the models for the children things. But it's very Active Record-like. It can be very Active Record-like if you want it to. Gorm will manage your migrations for you, which is handy. As you're bootstrapping your application, you can add new fields in your design, regenerate your code. The next time you start up the app, that field will be in the database. You can do full ORM operations. You can say, my model dot my child dot my other child, my field, and Gorm knows what to do with that. Or you can just grab the DB handle and execute your own SQL if you want to. And with Gorma, we expose that database handle to your controllers. So if you don't want to use the generated pieces of Gorma, you can go off and handwrite your own SQL wherever you need to. And you will need to. That's why we expose it. One of the things I really appreciate about Gorma is that it abstracts the database quite a bit. And so far, I found it to be pretty accurately. So I use SQLite in dev for my tests, but we ship with Postgres. Haven't seen any issues so far with that. That's been nice. So let's talk about what Gorma does. It understands your media types and your payloads and the views that you've created in your design. And then it generates fancy functions that allow you to convert from those. So not only does it generate the stuff to get a model out of the database, but it also does the hard work of saying, now we've got this model, but I need the admin view of that model. Gorma does that for you because it knows which controller you've called from, and it will create the smaller view or the link view or whichever piece that you need out of that model. So it does all of the conversions for you. You're not going to spend a lot of time taking a model and converting it into some other thing because you've already made that in your design and it's already done. It has pretty helpers, lots of them, because again, we know what's happening in the design. So we know what types you're going to be converting to different pieces, and it does all of the hard work for you. If a model uses like a belongs to or a has many relationship, Gorma knows that and will generate the helpers to filter the bottles that belong to this account, filter the users that belong to this company. It will do all of that for you, so you get the automatic protection of preventing somebody from listing all of the users in the database when they really should only have the ones that belong to their account, for example. And so that's Gorma. I'll show you an example of all of this code in just a minute. Outside of Goa and Gorma, we've got a nice handful of middleware that's being written. We've got a JWT package that allows you to create JWT tokens. And if you use OSINT, for example, for your OAuth server, the JWT package will plug in directly to OSINT and use your authorization. Doesn't have to, but it can. Then there's a log request and log response middleware. So if you want to log the inbound requests for security purposes or the outbound responses, you can. It's got an end-to-end request ID generator, so you can create a request ID that gets stuffed into the context, and that will go from the beginning of the HTTP request all the way down to the database in the context. So if you make a log call in Gorma, for example, because you're making a database request and it fails, it will have that request ID in it automatically. There's a automatic recovery, so if you get a stack, a panic, it will automatically recover and just send back a 500 error. Timeouts using Go's net context, so you can set a timeout in the middleware that says no request can take longer than 5 seconds, and if it does, cancel them all and reclaim those resources. That's wonderful for protection of slow request denial of service attacks. There's a require header middleware that allows you to require a basic header like an authorization or your own custom header if you want to. Then there's core support and gzip support. I like the logger a lot because it's pluggable. You write a couple lines of functions and you can use any logger you want. So the logging that happens in the API and Gorma, wherever, will go to Go standard log by default. But if you use Logress like I do at work, there's a tiny little function that you call to create your Logress instance and tell Goa that that's the logging information that it's going to use. And then Goa also has pluggable metrics. So by default, it won't emit metrics anywhere. But if you give it a metrics emitter, it will emit to Prometheus, StatsD, CollectD, a handful of others automatically. So what's coming soon? The security DSL landed today. I don't actually even know much about it because I haven't looked at that code yet. But it allows you to do things like specify the different security requirements per resource or for the whole API. So you can say that the entire API requires JWT tokens, but the auth controller doesn't, because you can't auth without a JWT token. One of the uses for that would be creating basic auth for retrieving a token, but then requiring a JWT token everywhere else. 1.0 is going to be stamped soon, and soon is nebulous at this point because we keep finding cool new things to add to it. We'll be adding more examples and more documentation, although honestly I'm pretty proud of the documentation that's up there, but it's a big concept, so the more documentation, more examples we have, the easier it's going to be. And then Raphael, we call the Godfather, will be speaking at GopherCon in July. If you haven't got your tickets yet, why not?
Where's it going?
Denver.
Denver.
There's a good story behind that.
Great time to do that.
All right, so let's look at some code because that's my favorite thing. All right, so Goa has, here's the website. Oh no, that's the Gopher Academy blog post about Goa. So let's go to Goa. Goa has an example application called Goa Seller, and it's a pretend wine cellar that lets you rate the bottles that are in your wine cellar. I think Raphael likes wine a lot. So you can see if you go through this, this app, it shows you what a good Goa application looks like with good, clean examples. And the design of the system shows an API that is called Seller. And the API has only 2 media types, an account and a bottle. So somebody registers for the system, creates an account, and then they can upload their bottles to the system. They can rate them, they can review them. It just allows you to keep a listing of all of the nice wines that are in your cellar. So it's a relatively small API, but it's very well written, so it kind of exercises all of the corners of Goa. You can see what validation requirements look like in a media type, for example. So this rating can only be between 1 and 5. Here's an example of different views. So there's a default view that has a lot of stuff, and then there's a tiny view that only has a little bit of stuff, and a full view that has everything. For this particular, I think this is the account, or this is the bottle. And then,
How does that translate to when you call the API? Is it a parameter on the route that tells you which view you want, or
no, it's actually in the controller that you would choose. No, you would choose which route you want to send back. In the resources, you can define the view that gets sent back. So let's see here. So the response would be created. Where is my list? Oh, here we go. So, and this is the list bottle resource, and the response is a collection of bottles, and it will either send back the default view or the tiny view. And somewhere in your controller, you're going to know which one you want to send based on who's calling or why they're calling or where they're calling from. So you define the different views that could be returned, and then the controller is the thing that makes the decision where that happens. So I thought for our meetup today, it would be useful to take this Goa app and add Gorma support to it so it automatically has database access. So I did that instead of Goa Seller, we've got Gorma Seller. And I wrote this late last night. It's exactly the same design as the Goa Seller. In fact, if you look at my design, it actually just imports the other design. And the only things that I've added are the things that make the database work. So let's walk through this quickly. Gorma has the concept of a storage group, and a storage group is it's the master definition of storage for your entire company, in theory. Then you can have a data store. This one's called Postgres. And the idea behind multiple stores is you might get data from Redis, you might get data from Postgres, you might get data from MySQL. Today we don't generate more than one store at a time, but there's nothing preventing us from handling multiple stores in the future. So at some point in the future, maybe you're going to do authentication against a Postgres database, but your main models come from MySQL. We're future-proof prepared for that. So in your design definition for Gorma, we have the concept of models, and a model is a table in the database. And then we used a handful of DSL definitions that describe the relationships between the models, the media types, and the user types. So this DSL renders to says, we're going to take this model from the database, and we're going to create the account media type from it. So that function renders to tells Gorma to generate code that takes an account out of the database and generates an account media type in Goa. We also have description. Because we're in a database, we need to have a primary key. So if you remember, there was an ID field on each of those media types in the seller definition. So I'm just overriding that field description and saying this one's going to be a primary key. Then I added a name field and has many relationship. So this account has many bottles, and a collection of bottles consists of one bottle. The bottle model has some interesting things in it. This builds from those user type definitions. The payloads for the posts and the puts are called payloads, and the builds from DSL tells us that we're going to take this payload and convert it into a model in the database. So builds from will generate the helpers per resource and action to take that inbound request and turn it into something that we can insert into the database. And then again, renders to, it just says we're going to take this data out of the database and create a media type out of it. And I think that's pretty much it. Has one declares that this bottle has a parent account for model. So let's look at code. All this talking is boring. All right, Gorma Seller. So we started with the design, which you just saw online. Is that readable for everybody? Okay. And then from there, I created shell scripts to regenerate the stuff because why type it more than once? So I generated, the first time we did Bootstrap, but then the second time I explicitly showed you which pieces that can be regenerated. You don't have to do this every time, but why not? It's easy to do when you have a single source of truth. To call Gorma, you use the generic generator function called gen, and you pass it a package path to the generator. So Gorma is my generator that I'm going to be calling. It reads the design, and then it creates its own code generation bits. So let's look at one of the controllers. Actually, let's start from main and go backwards. So in main, the code that was generated was about 10 lines less than this. The only thing I've added to this code is the chunk up at the top that connected to Postgres. And then I added the automatic migrations for Gorm. And that's it. I connect the database and create a new Gorma model for the accounts and for the bottles. Set the max open connections on the database handle to something higher than the default of 5 or 10 or whatever Go gives you for database SQL, because I'm going to load test this tonight, and that's fun. And then I use a handful of Goa middleware, the request ID middleware, to assign a request ID to every inbound request, tell it to log the request, and the recovery middleware just in case we have a panic, which won't happen. And then we start up the app. So let's go backwards and look at a controller. I did not implement the bottle controller just specifically so I could show you what happens when you generate a Goa app. You just get a bunch of TBDs, implement this, and it returns nil. If you were to run this app and then call a resource that returned a bottle, it would send back a not implemented HTTP call. I don't even remember what the code is, 40 something, not implemented. But I did attach Gorma to the accounts controller. So you can see we went from, in the create, for example, we went from TBD to, what is it, 6 or 7 lines of code that take the inbound request, which has already been validated. We create a new model from that payload and add it to the database. We create a header that has the location of the newly created record, and then we send back the response using that created template that we created in the API definition. Pretty much the same for all of the rest of the functions in the API. Show gets 1, and all of these, one account or get, all of those are the functions in Gorma that are generated based on your design. So we know that controllers are pretty lightweight. If you had any extra business logic, you would put it in here. Let's look at the modeled code that is generated from Gorma. We start with an account, and it creates a model structure. Model struct represents the data that's stored in the database, not the data that's being sent back to the consumer of the API, not the data that you're getting in. This is what's stored in the database. So this is what you consider your canon of data. It uses a handful of Gorm definitions to tell Gorm how to store it in the database, so it knows that an ID has to be the primary key. And then
What is one of your time of pointer?
actually, that's a great question. Gorm allows you to do soft deletes. So instead of deleting to the data, it just adds a date stamp to the deleted at field. And then it uses a filter. When you're retrieving data from the database, it automatically filters all of the data that isn't deleted from the system. But you can unfilter it and say, show me all records, including the deleted one. So it's a way to hide the deletions and not make the data disappear from the system. And you get that for free because of Gorm.
So
You don't have to use it if you don't want to, but it's nice. Why not? And it automatically populates the created at, deleted at, and updated at fields every time you touch that record or create it.
So the pointer makes the nullable field.
Correct. Yeah, and you'll see that a lot in Goa everywhere. In your, where's the Goa Seller? In your design, I'm going to go back to the Goa Seller design. You can see required fields, and here we go. So there's a required field for name. Goa will translate that required field into a field in a struct for the media type, and because it's required, there will be no pointer. It's either there or it's invalid. If it were not required, then it would be a pointer. So you can tell the difference between Go's 0 value, which is an empty string, and a field that wasn't given to you, which is null, because it's a pointer. I hate pointers a lot. I really do. I came from dynamic languages. I just hate pointers. But this makes a lot of sense because now you know whether that field was populated when it came to you or whether it was not populated and you're getting a default value. You had a question?
Yeah, I saw basically you generate the tables or the database from this model.
Correct.
I saw one thing, and I want to ask how you separate between the naming conventions, like you have models that returns as a JSON in a different naming conventions, and then you have a Postgres that supports only you know,
That's a good-
lowercase?
That's a good question. There's a function inside Goa called Goify, Goify, and it just means take this field and turn it into something that Go can use as a name. We use Goify everywhere. So if you send in something that's camel cased, but you're using it in the database, you need to have it snake cased. It will create the snake case version for the database. Gorm does a lot of that for us too on the database side, but on the Goa side, almost all of that happens automatically because of the code generation. So if you give it a model name that is, or I'm sorry, a media type field that's called first name, and there's an underscore first underscore name, when it's created in the struct, it will be camel case first name with the name, the capital N in the name. So it does all of that for you.
And it goes past all days.
Yep. And it will also create JSON tags for those. Let's look at the media types that were generated from these, and you can see the JSON tags that were generated for the account. So the ID has a JSON tag with ID. The name has a JSON tag with name. So it creates all those JSON tags for you. Something that I didn't discuss earlier, all of the encoding in Goa is pluggable. It comes built in with JSON encoding. But you could actually use protobuf encoding if you wanted to. You could use message pack encoding. It doesn't care as long as there's an encoder for it that you can plug in. And that's really handy if you talk to different kinds of systems other than things that expect JSON.
Is it good enough to know when you use a keyword and try to escape it, such as null or class or things like that?
There's a list of keywords that it won't allow you to use. So the generator will catch that before you try.
And another one, does Gorma create a client extension just like what Goa does, so that if you wanted to make a script that just reads out of the database,
Gorma
does it do anything like that, or is that
Gorma is a package, so you can import the models folder from your API anywhere else if you wanted to use that directly.
And just make your own command line interface?
Absolutely, and at work I do that. I've got a tool that creates seed data for things. You know, you create a new account. I've got to create 1 million records somewhere, so I just import that models folder from my API, do a bunch of stuff and save, and it's done. So yes, good question. So the generated code creates the struct that represents the model. It also creates a table name field, which is a Gorm convention that allows you to name the table something different than the model name. So if you've got a users table, but the table in the database is called people, you can have your model called users, just override the table name in the design of Gorma, and it will generate a new table name for you. Same with the fields. If you want to rename a field in your struct and have it have a different name in the database, you can do that too. So you can actually attach Gorma and Goa, then by extension, to a database that already exists. It's a little bit more difficult because you have to reverse engineer everything through the system, but it's absolutely possible, and I've done it. I create a storage interface for each model so that you can stub out your database calls with mocks. And you know, I'm a big fan of testing, so if you want to test the things that happen in your API, you can create a storage interface and use that storage interface instead of the models that are created. Allow you to test without hitting the database at all. And then each of these next functions are just the basic CRUD. So there's get and list and add and update and delete. Those aren't the ones that are typically called from your controller. I generate them as kind of a convenience because these will return models. They will return database models. They don't return the media types or payloads that you need. So those are all here in the helpers. So if you want to list an account, the accounts in Goa are stored in the media types in the app folder. And the list account in Gorma, in the models, will return back an array of media type accounts. And it does all of the cool stuff using this account to account function that's generated that knows, based on introspection or using the design, it knows how to convert your string in this database to an integer in the media type if that's what needed to happen. So all of these conversion functions are generated based on introspecting the design. Every different view gets its own conversion function as well. So if you know that you're going to be returning tiny view or the admin view or the default view, there will be conversion functions for each of those views. It's a lot of code you don't have to write.
You know, something that comes to mind now is I'm assuming you've heard of something like Downpour, where your data can actually link through URIs. So do you have any sort of generation that's that goes with this that would say, oh, by the way, give me, you know, a link to when you say has many?
Yeah.
You actually get the links for the
Great
has many?
question. And actually Goa does that for you automatically. If you go back, let's go back to the Goa Seller bit. And the account definition here has a link view. See that link view, it has an ID and an href.
Yeah.
So if you go back to a bottle in the definition of a bottle has a links DSL function, and that link has a link to the account that owns the bottle. So what's going to happen is it will generate code that every time a media type of bottle gets sent back, it's going to have a links method or a links chunk of JSON that has a link to the account using the two fields that are listed in the link view of the account. So you get that almost that JSON API feel where it's got resource URIs for every resource that you send back. That all happens automatically. Yeah.
So is there a possibility of putting something on the list that's attributes for, like, you know, you don't want a string being 255, but the whole.
Yeah, absolutely. You can change at the database level. You can change the field size. On the Goa side, you can say these strings are 1,000 characters, or
And it will respect it over there.
all the way down. Yeah.
Sweet.
All right. So we looked at the helpers. We looked at the stuff. Let's run this sucker. So I showed you that I built little scripts to run everything. I have a Docker script that pulls up Postgres, generation script. I'm not going to generate it again because the demo guys have been so good to me tonight. I've got a launch script that removes the existing executable, builds it, and runs it. Let's run that real quick. Builds the app and runs it. You can see the pretty logging. I turned on automatic debug logging in Gorm so that you can see the database calls that are happening. And now we've got an empty database. So let's make a post to create a new account. I saved in Postman. I saved some of these. So let's post to seller accounts. And we got back a 201 created. Let's look at the headers. It came back as seller accounts 1. So if we do a get to seller accounts 1, send it, we get back the created at field and the href, the ID, and the account name. So you can see that it went all the way through the database and saved it. Let's go look at the log file. Here's the log file where we inserted, and then the log file later where we pulled it back. If the account actually had bottles attached to it, they would have come back too because they were defined in the view. The account lists its bottles in the view. You can see the select call that tried to pull data from the bottles. So Gorma understands that views might have children objects in an account listed in its view that it had bottles. So it's going to retrieve the bottles too because that has to happen to satisfy the view. We can update and delete. So let's update the account. And let's make it Bob's account. Send it. Should make sure that it's sending to accounts 1. So we get back a 204 no content. Let's look at the database. And it says updates account. Name equals Bob's account. So if we get it again, it better come back Bob. And it does. So I only did the accounts controller. I didn't wire up the bottles controller just so you could see the difference between what Gorma needs and what Goa generates by default. 5 or 6 lines of code get you all of that great database access. But let's load test this because I love load testing. Load testing makes me happy. So I have a script. I'm sorry?
Is it the Vegeta script, or is that not Vegeta?
Yeah. It's right here. and that's just going to do a get on accounts 1 repeatedly. Let's look at it real quick and show you what it's going to do. It's going to do a get on seller accounts 1 for 20 seconds, and the default with Vegeta is 50 concurrent connections. So that's why I upped the pool earlier. And then it's going to compile all of that and give us a nice report at the end. So let's run it and see how fast this thing is. You can watch the logs flying along with millisecond response times.
Milliseconds, that what that code, that different code to go measure since. That's what it does.
Yes. So we have Goa automatically captures the response time and the metrics about the request itself, and then Gorma captures data about the database access layer too. So if we were to pull up StatsD, which I forgot to hook up, I don't know why I didn't remember that. If we were to pull up StatsD, you'd have a nice graph of your database response times and your controller response times. That all happens automatically if you connect it to StatsD.
So doesn't the flushing to terminal kind of slow it down a little
It
bit?
does. It slows it down quite a bit. And if we were to pipe this to a log file, it would be much, much faster. But let's look at the results we got anyway. Latencies, it's awful. Why is that terrible? Let's do it again. That's really bad. But we see we got no errors back. It's all status code 200. I don't understand why it's so slow. The ones I ran this afternoon, the mean was 4 milliseconds for the full round trip. This is ridiculous, though.
You might be benchmarking your terminal.
It's possible.
Mhm.
Yeah.
There we go. That's a little better. Let's pipe this to something. All right. Try again. Oh, it's going to fail. Got to post. We have to have a piece of data there. There we go. Now we can load test it. While it's running, any questions about Goa, Gorma? Yeah.
You mentioned before in the slide that context, package context everywhere.
Mhm.
Can you explain more?
Sure. In fact, I'll walk you through it.
Why you use that? Because I saw you using different places.
Oh, that's so much better without the logging, by the way. Here's our response times. Mean is 5 milliseconds. The max was 15. That's 50 concurrent requests. Nice and fast when it's hitting the database. There's no caching there at all other than what Postgres does automatically. So it generates pretty code that's fast too. There you go. All right, so let's look at the context. If you look through the code, upstream from your controller, the code that's generated contains a context for every method, every controller and every action. So if you've got an accounts controller with a create action, there will be a create account context. So here it is right here. So the create account context is actually a named type. It's a type in Go, so that there's strong typing for every controller and every action. And that's something I really appreciated when I first found Goa, because you know where you are in your code. It's got extra pieces attached to it that you normally wouldn't get if you were writing some sort of generic API. So this one has the context embedded, and it's got Go response and Go request, so you can get to the HTTP request and you can write a manual response if you need to. But then it also has a payload. So the context.payload is going to be a create account payload, because we know what fields are coming in the create account request. We designed that. If I go to the definition here, a create account payload has a name, and that's it. So if I were going to access that from my controller, I actually do right here, context.payload.name. I don't have to worry if it's null. I don't have to worry if it's empty, because that already happened. All of that validation happened upstream. It wouldn't even hit my controller if that data that was posted is bad. So you reduce a lot of error checking up front. So that same context has the HTTP request and response, It's got an embedded Go net context in it, so you can use the cancellation features for timeouts. You can add your own pieces of information to that context, pass it somewhere else, and they can pull that information back out. And then we take that same context and we pass it into Gorma when we're doing our calls. So Gorma, all the functions in Gorma accept a context as the first parameter of the function. So that same context goes from the beginning of your request all the way down into the database, and that request ID that we created earlier is in that context. And so is the information about the payload. It's a nice way to have a container for all of the information about this request through the entire system. Does that answer your question?
Yeah.
Okay, good.
At what point do you think it's the cost of working with a model like this is lower than writing all of them a bit by hand? If you're writing just a 2 endpoints microservice, would you just do it in pure Go, or would you use Go?
I would use Goa for any microservice at this point, because now that I've spent a couple weeks, really digging into how the designs work, I appreciate all that I get out of it. And I know that if I were to use that same pattern in all of my different microservices, whether they're tiny or huge, I know exactly what to expect. And I can make my own extensions. For example, we had a custom authentication that we required at my job that hit LDAP or something silly. I could make that as a Goa middleware and use it on all of my different microservices. So for me, it's about standardization. And you saw how small that design code is. The investment in time to create this design for a 2 endpoint microservice is a couple hours. Spend a weekend reading the Goa.design website, get those concepts, spend 45 minutes writing your design, and you've got a full microservice ready to go. And with all of the middleware that you would need for authentication, for logging, metrics, all of that stuff. So for me, the benefit doesn't really matter based on the size of the microservice.
That's really for initial setup, but do you think that once you have that app defined and generated, do you keep working within this definition, or do you work on the generated code?
I would never touch the generated code. In fact, the Goa generated code automatically gets deleted every time you regenerate. Gorma doesn't do that. In Gorma, the models folder does not get deleted every time, but the code that it generates, the account.go and account.helper.go file, those two would get deleted. So if you wanted to add a Brian's account.go and add custom functions for database tools, you can, and they won't get deleted. So that's the difference between Goa and Gorma in terms of what gets deleted. I couldn't live with the idea that you wouldn't need some extra database thing somewhere. And I have those in my work APIs that special code for authentication or whatever that has to do something unique in the database that I'm not going to spend the time to generate. I just need this one function. So when we regenerate in Gorma, it will generate these standard files and delete the old ones, but it won't touch your custom code that you've created.
That was my question as well, like where the generated code ends and the custom code begins. So if I understand correctly, all your business logic stays in the DSL and just regenerate that every time.
So the definition of your API stays in the DSL. All of your business logic goes in the controllers or whatever packages you write and call from the controllers. So in a larger app like my work API, which I can show you later, this is actually, the API is just the command. It's the thing that runs the API. All of the business logic is in hundreds of packages that are somewhere else off in a different folder completely. Sometimes we're just getting stuff from the database, and that's easy to do. Sometimes we're calling this gigantic business function that has 10,000 lines of code elsewhere, and then returning a result from the API. But in terms of where that delineation is, everything in the main folder of your API is fair game except custom code that you put in models, your main.go, and your controllers. None of those will get deleted, but everything else can and should. So to kind of go back to your point earlier, let's say that we've had our API out for 6 months and our customers say, this sucks, we need another version. You would go into your design, create version 2, and maybe it inherits some of the media types and payloads from version 1. Maybe you add more. So you can make whatever changes you need for version 2 and layer that on top of version 1, generate again, and now you have both version 1 and version 2 in the same code base. You didn't lose any of the stuff you did for version 1. You just created a newer version on top of it, and you gain all of that custom work that you already did in your controllers. So that's how I see the life cycle.
Earlier in the talk, where you listed 2 new lines you have to that.
Uh-huh.
Where were those? Were those in the DSL? Like,
The lines, the things that we added for DSL support are right here. It's one file, and this is it. It's a storage definition that determines how you map media types and user types to the database.
I have a couple more questions.
Sure.
The first one is there also speaking of versioning, is there a deprecation warning piece that you can add in there for, say, this field is being moved to this, or this field may or may not work for future versions?
There isn't
Anything like that?
there isn't an explicit deprecation warning, but every model, every field, every type in Goa allows you to attach a description.
Right, it
And
just has to
you
be-
could put that deprecation warning in the description, although it seems like a really nice feature to add. You know, a deprecation, this particular model or this field will be deprecated in a future version. I like that idea. I'll probably open an issue for that.
And then the second question is really not just, it feels like the stickless question, but I'm curious, how big are the binaries that it generates at this point?
Let's take a look.
Go ahead, 80% runtime, and then you have
Oh yeah, I know it's,
So it's 13 megs, and that's Go 1.6. If I were running the new SSA, I bet it'd be even tinier, because
yeah.
I saw some posts today with really tiny compile sizes.
One of my Go apps are 13 megs.
Yeah.
All the same size.
So it's not a big binary.
Oh yeah, I'm curious, really truly curious. I've seen some people have varying results with that, and it's interesting because it just depends, I think, on how people use generation. And I guess I was going to originally ask way earlier in the talk why you chose to use, or why I guess Goa chose to use its own generation app versus using Go Generate or some of the other pieces out there.
You can use Go Generate.
And I would imagine that the problem would be that you just don't get the ability to go in and do things like, oh, run this plugin, but with the context of this Go Generation.
Yeah. It's more of a,
So,
I think, I can't speak for Raphael, but it's more of a chicken and egg issue. So you have to have an application, or you have to have a thing to run Go Generate on. In our case, the design package is not where you're going to be generating to. So you could create a stub main.go file and run Go Generate with GoAgen, and it would work, but there's no need. We've already got GoAgen, so it's not necessary to do that.
Back to the capabilities of Gorma. So one of our production systems uses a lot of the more advanced features of Postgres. It's got like table inheritance, it's got permission tables, it's got PGSQL functions that generate code from IDs. Are those things that are like kind of, I guess, outside the realm of being able to wire up an app with Go and Gorma, or is that
So you can write custom database functions and use them from your controllers, and they wouldn't get overwritten. But in terms of the things that will get generated for you, none of that is supported out of the book or out of the box. But it wouldn't prevent you from doing that yourself. For example, UUIDs is something that I intend to support really soon. Not having to use integers for IDs is got to be web scale.
I mean, Go or Gorma is opinionated. You have to follow patterns.
You do, but you don't have to use integers for primary keys. In fact, if you've got a table that does a join table, so you've got users and bottles, and you've got a user bottle table to join the two of them together, it might have 2 fields as its primary key because it's a join table. You can do that in Gorm, and you can do that in Gorma. Gorma understands join tables already. So some of that is already in there.
More complex. For more complex structures, what I often do is part of my struct is somewhat static, so it becomes its own set of columns. And part of it would be a JSON column, and we'll put a whole bunch of stuff inside the JSON. So it's kind of a hybrid model. Where you
Sure.
have part of the table that's a document database, and the rest is
Yeah.
just a field that I use to query.
And in theory, Gorma supports HStore, and I've never tried it with, I'm sorry, Gorm supports HStore. I've never tried it. There's no reason it wouldn't work, but it's never been tested. So you could do that. It just hasn't been tested.
It's the default authentication method with that. So
The default is there's no authentication. You have to choose some, and that's where you get the JWT middleware if you want to use that.
Do you know if there's a middleware for Vault?
There is not a middleware for Vault.
do you have a recommendation?
For authentication, I've actually got 50-ish% of a, I don't know what to call it. It's more than just authentication. It's almost, what's the one in Ruby? There was one I used a long time ago on Rails. I have something close to ready that will generate the user table for you and all of the authentication functions for you, and it's opinionated, so it will use JWT and tokens. It will create the auth controller for you. It will create the correct fields in the database. So if you want something that's canned out of the box that supports, you know, the 80% use case for authing against your API, I'm not far off from having that done. I just don't know what to call it. And I don't know how deep to make it opinionated.
Like Hawk. I don't know if you use
Hawk is very nice, yeah.
Hawk is nice. It's,
I like it too. It's created by the guy who left OAuth because it got too complicated.
fuck this. Here's
Yep.
something simple.
Very good.
It worked great for if you have microservices, you need to talk to each other, or a lot of more like web browsers with clients that need to talk to your API. It's nice. It's really just an HMAC of request and request button.
Yeah.
You just keep talking. But it's clean.
Yeah, it's very clean, and there's a Go client for it. I wrote a Hawk API a year and a half ago. It was very nice, worked well.
Does it use auth before?
I started, in fact, if you look at the original Gorma code, it had authboss embedded in it. And I've started looking through the authboss code on GitHub, and they've kind of abandoned it. And they also said they really don't like their design now. They wish they had redone it. So I walked away from authboss. I would like at some point to do something like authboss, and that's kind of what I'm hoping that this next plugin that I write will be authboss Lite. You know, just enough to get you authenticated and secure in your database. Not a user management Django app, but you know, just here's my users and here's how they can auth and get tokens. That's it.
Yeah, so store the sessions in the database.
With JWT, you don't need any sessions. You don't need a database. You put whatever information you might need in the token itself, encrypt it, and that goes back and forth, so there are no sessions, which is one of the reasons I love JWT. It's got some limitations too, but the nice thing is you don't have to have sessions with JWT. So if you look, let me pull up some code here.
The main problem is invalidation.
Yes, so I always use really short token length times, you know, 5 or 6 minutes, something like that, because if you needed to invalidate a token with JWT, you'd actually have to store the token in a database and then check its validity. It defeats the whole purpose of not having sessions, so I just use short token times. But yes, that's a very good point.
Actually, with Hawk, I recently implemented an API with an LRU cache to prevent the replay.
Mhm.
The issue is sharing the cache. So you could use that with Redis or Memcache and just have a Redis or Memcache to store all of your unique nonces for all of your authentications and make sure they're not replaced.
Yeah. There you go. All right, I'm going to stop my screen sharing thingy. What's it? Who knows if it worked? I never checked